Dear friends, welcome back. Yesterday we have studied some preliminary part of the chemistry, and I told you that since childhood I wanted to become a chemist because I like chemistry. Even if you talk to any child anywhere, kids, they will be interested mainly in chemistry rather than physics. They are interested in biology only to see the animals and see the shapes, etc. But to study the things, they are very much tempted to study this particular chemistry. In Marathi we call it Rasayan Shastra. So it has got some juice in it. The chemistry has a juice, so it is tasty. So naturally, everybody wants to make some such solution which will make them God, which will make them anything. So there is a magic between this particular chemistry. That doesn't happen in physics. Therefore, everybody was interested in chemistry, and chemistry also shows so many different transformations of the materials. It may give rise to sound, it may give rise to light, it may become completely different color, and there may be rainbow also. So many things you find. So in the nature, whatever are the new sensational things, those can be shown by chemical reactions. And chemical reactions we have seen, they are of two types. One is the inorganic reactions and organic reactions. Now inorganic reactions have no limit of temperature, pressure, etc. So if a volcano is there, the temperature is very high. At that time, there are so changes in the metals and so metamorphic rock may be produced. There may be so many other changes which are occurring in the nature due to very high temperature and other things. So many engineering industries and chemical industries evolved on that basis. They could take out the ores, extract the metals from that, extract the different chemicals. They can separate the chemicals and they can do many things, prepare many, say, weapons and tanks, cars, everything. They could do it everything from this inorganic knowledge of chemistry. And therefore, chemical engineering deals mainly with that chemistry which doesn't have any bounds of temperature, pressure, etc. However, Earth has got an exceptional property of life. There is a life on Earth. So we have got a plant life, we have got the animal life, we have got microorganisms, and above that we have got viruses also. Everybody now knows about virus. So right from virus to a big dinosaur, we have got such a different animal kingdom. Similarly, plants also you can see. The plants can be even from unicellular to a very big trees are there. And not only that, in the sea, about say 2/3 ocean. So just generally, so sound every phenomenon, inorganic chemistry, some other material, plastics and other things. But life is something different. Life has got entirely different type of chemistry, which has got a specific bounds of temperature, pressure, and so many other things. And that is why we are studying organic chemistry. And when the organic chemistry is considered, at that time there will be more main importance of water in it. So let us first review whatever we have done last So in yesterday's lecture, I have told you that chemicals are formed by joining different atoms. Atoms may exchange the electrons and form stable groups. So oxygen atom doesn't remain stable in nature, so it becomes O2. C and O2 becomes CO2, and CH4, that is 4 electrons are there remaining, so 4H will join there, it becomes CH4, and so many such chemicals are formed. Even SiO2, Si will combine with 2 oxygens, and like that in the nature there are so many chemicals and minerals formed just by composition of inorganic materials, and through that there were acids generated. These acids created a havoc because these acids have dissolving power of all minerals can dissolve in it. Similarly, bases also have got similar power. So acids and bases play an important role in chemical reactions. But this particular thing happens only when there is a water. Water is a prime mover in all that thing. And this water, if you see, H2O is generally present as H and OH. So H is hydrogen ion. It is positively charged. It has lost the electron. It has OH has taken the electron. OH becoming or being more strong. If you find the weight here, this will be 16 plus 17, and this has got only 1. So this is a tiny person. But this tiny person has got the greatest power of making changes in the entire world. So how it is possible, that we shall see. When we are seeing the strong acids and strong bases, strong acids you know the strong acids, say HCl. HCl gives H plus Cl, H2SO4 gives 2H plus SO4, HNO3 gives H plus NO3. Now these are the main strong acids. Strong bases are NaOH, KOH, so we can also say that those compounds which give H by dissociation, those who give OH after dissociation are called as alkalis. And when these two are combined, you get salts. So if I take NaOH plus HCl, you get NaCl plus H2O. So NaCl is a salt. So alkali or base, acid, you get salt and water. This is true for all these things. You may change this alkali also any time, like NaOH, KOH, CaOH twice. CaOH twice also, lime also is a alkali. There are so many other things like NH4OH, ammonium hydroxide. All hydroxides are bases, and all those who have got H in the cation position are called as acids. This you know. The important thing here is when HCl goes in water, it completely dissociates. There is no molecule of HCl in the water. when it goes in the water, it just splits itself into two. Similarly here, it splits into two. OH will go, randomly go, K will go anywhere. So water will contain either this, either this, either this, either this. So water is a host. In the water, once you add that, this will get completely separated and then the process will change. Now if you are just finding there is some acid in the water, acidity is there, and I want to make it neutralize. What is the neutralization? If acid is there, we add alkali. When we add alkali, what will happen? OH will be added. Na will not have any importance. K is not having any importance. OH is important because the H2SO4 added has given 2H. This has created acidity. Now this has created acidity. To neutralize this, I want OH. So I use 2NaOH where there will be 2OH. So they will combine and this will be neutralized. Remaining will be the salt. This is remaining portion SO4 and this will become a salt. So neutralization is a very, you can say, primary method of treating acids and alkalis. If something is caustic, you add acid. Something is very acidic, you add alkali. We were also of the same opinion when we were doing some study in industrial waste treatment. We were given a job. So we were given a job of treating textile waste. Textile waste, you know, they do mercerizing. Mercerizing is by so mercerizing, you know that mercerizing use a caustic soda solution is there, and in that the raw cloth is dipped because this caustic has got a property of dissolving all organic matter. So all dust from that cloth is removed and that becomes white, a clean cloth. But this mercerizing waste is having very high alkali, and we wanted to make it neutral. Because in the nature, if it goes alkali, it will spoil the entire soil and other life. So what we did, in Ichalkaranji we were treating it, we building a tank, we have put all that mercerizing waste, and then we said, we can do it by HCl or H2SO4. We put a tank and we added H2SO4 just to match whatever mercerizing waste is coming, so that it could be neutralized and there will not be any danger, only salt will be there. We did it, and in the 8 days we were called by alarm. They said that your tank is completely empty, it is started leaking. So we rushed to that place. We found that slightly the dose of acid was increased. Slightly it was more because the waste was less. Once it is more, the entire thing became acidic. It became so acidic that the tank started leaking due to the eating up of the cement by cement that is making calcium. So calcium is dissolved in this particular H2SO4 and it started leaking. Then we understood that neutralization is not so easy of strong acid and strong bases. So strong acid and strong bases, so even if you neutralize, the neutralization is very critical. Even if one drop is more or less, if it is less, it will be too acidic. If it is more, it is too alkaline, like that. So this is a very sudden change. We shall see how that change can be measured and other things. Now, as contrast to the acid and alkali or the salt, which dissociate completely 100% in water, water itself doesn't dissociate at all. It dissociates to a very minute range. So H2O, that is, what is H2O in water? So H2O, H plus OH, you might have expected that water means nothing but H and OH. It is not so. Water is completely having water molecules. Only very few molecules split in H and OH. So if you take a glass full of water, out of that all will be molecules H2O. There will be very few H. Very few H. So this particular H2O is neutral. It doesn't take part in any reaction. H2O is completely without any parting. H and OH both are fighting each other, left and right. So they are active. And in that also, OH is dull. It is not so active. So H is active. So H ion concentration is the main thing which changes the reactions. So we first remember this is a very small dissociation. Dissociation is very small. So less dissociation. So most of the water in natural state remains as water. Now there is a rule that they have found out that the product of these reactants to the original is constant. So if I say OH upon H2O, that means product of the two ions split H10OH upon H2O molecules. This remains always constant. Now this particular square bracket is considered as a molar concentration. Molar, we have seen what is molar concentration. 1 gram mole means 1 gram mole will contain 10⁻23 atoms of H. 1 gram mole of OH will contain 1 gram mole means how much it will be? 17 grams. 17 grams of OH will contain 10⁻23 OH ions. H2O similarly. So now H2O, what is the weight here? 18. So it will be 18 grams will contain 10⁻23 H2O molecules. So such is the case, and this is the reaction rate constant. This is called as reaction rate constant. Okay. Now this H into OH into this molar concentration KWH H2O. If you consider this is 1 mole, then you get this is equal to 1 or 10 raised to minus 14. H into OH is 10 raised to minus 14. What is the meaning of this? 10 raised can't measure also. But 10 raised to minus 14, that is 1 upon 14 joules. Such a small thing. Now this is the multiplication. Now wherever in the water, whatever is the number of H, the same number we have of OH. So both must be equal. So if both are equal, what will be concentration of this? This is concept multiplication is 10 raised to minus 14. So A into B is 10 raised to minus 14 plus, however, A is equal to B. So what will happen? This must be 10 raised to minus 7 and this should be 10 raised to minus 7. Multiplication, when such thing is there, there is summation here. So 10 raised to minus 14 is 10 raised to minus 7 of H, 10 raised to minus 7 of OH. That means neutral water will have hydrogen ion concentration. Neutral or pure water, H ion concentration is equal to 10 raised to minus 14. Sorry, 10 raised to minus 7. Now in it, suppose I add as HCl. Even if I add say in a liter of water, I add say 2 or 3 drops of HCl. Even if 2 or 3 drops of HCl are added, that whatever is its milligrams, that will be split completely in H and Cl or H2SO4, H2 and SO4, and that H concentration will be too high as compared to this, and then there will be a suddenly too much concentration of H in this particular mixture. So this water plus HCl say, the H will be too strong because HCl will give all H to that. This is very small, this is very high. So H will become very strong and this will be too much acidic. So the water